Hello everybody and welcome to another episode of Future Engineering Bets, where we look at advanced engineering and the future innovation in that area, specifically with electrification, clean energy and sustainability. I'm Fred Warner and today I am joined by Mark Grain of Extreme H, and I'm very excited he's joined us. So you're the world's first hydrogen-powered motorsport, sanctioned by the FIA, as you say.
We want to demonstrate that hydrogen-powered vehicles can operate and race in very tough terrains all around the world. That's our objective.
What do you say to the critics that say hydrogen doesn't have a place in general mobility?
You'll always have critics at any stage. And I'm quite sure that there were people who were immensely worried about having a tank of fuel in a car back in the early 20th century, for example. Hydrogen has got, in some quarters, some nervousness around it. We've been racing with it. It's another fuel. Part of our mission is to dispel a lot of these myths. Let motorsport be the testbed. Let motorsport trial all of these things and then feed that information back to the motherships everywhere, back to Tokyo, back to Dearborn, back to Detroit. Let it motorsport do all of this work. Prove out these technologies rapidly, because your next deadline is your next race.
Hello everybody and welcome to another episode of Future Engineering Bets, where we look at advanced engineering and the future innovation in that area, specifically with electrification, clean energy and sustainability. I'm Fred Warner and today I am joined by Mark Grain of Extreme H, and I'm very excited he's joined us. Hello and welcome. Lovely of you just to join us. Do you want to say a bit about yourself first?
Hi Fred, and thank you very much for inviting me on. Yeah, so a lifetime spent in motorsport. I won't bore you with winding back all the way, but most recently, nearly 30 years at McLaren across lots of different categories of racing from McLaren, but predominantly in Formula One. Latterly, my time at McLaren, I was involved in forming the Extreme E team, which gave me an introduction into the championship Extreme E and Extreme H that I worked with for the last 3 years. So yeah, lengthy time in motorsport, and currently technical director for the Extreme H championship.
Brilliant. And I think I know when you say a lifetime in motorsport, but for those that are motorsport fans, you know, when you talk about your 30 years in McLaren, you've got a huge amount in the GTR program. You've won them on.
Yeah. So prior to joining McLaren, I was with Williams in Formula One in the early 90s. So there were good times there, winning championships with Nigel Mansell, for example, and then moved to McLaren. I saw a great opportunity there There was McLaren Cars, as it was a division of McLaren, quite small, growing and expanding. Knew that they were going to convert the famous three-seater F1 road car into a GT car to go to race at Le Mans, and that's what I joined to do. Yeah, to your point, we won first time out in 1995 with F1 GTR Chassis 01. Fantastic time. And then quickly that expanded with more involvement from BMW and so on. So that division was growing, gave me the opportunity to grow with it. And then Formula 3000, which is Formula 2 equivalent to these days, took over a crew chief role there, number one mechanic role. And again, we won a championship there, so that was fantastic with the German driver Nick Heidfeld. And then back into Formula 1 in an R&D role. So now I'm looking at data and so on and expanding their career out that way, which really, again, a fantastic opportunity to really push and expand and take on more engineering and more technical roles.
Really interesting times, I suppose, with Lewis Hamilton's days at McLaren.
Yeah, I was in Formula One with Lewis. I was the chief mechanic for the first time Lewis drove a Formula One car, and then I was team manager for the first time that Lando Norris drove a Formula One car as well. So two personal little firsts there with working with those two drivers. That's quite a privilege.
So you've got a genuine, unquestionable motorsport background and heritage there, Mark, which is really, really exciting for people listening. Tell us, so you're in Extreme H. Tell us very quickly what Extreme H is for the layman.
It's short format racing. It's off-road racing. We race on really tough terrains. We have like 15 minutes. We've got three different styles of racing. One is a time trial, which is more like a rally stage from going from one point to another point. And then we have our head-to-head. So that's two cars racing each other over jumps and so on. And then we have a traditional, like a lap And this is all in, like I say, over rough terrain and all on circuits that we carve out. We don't race on tarmac. We mandate 2 drivers per team, and that must be 1 male and 1 female. So we're unique in mandating a female driver for our race cars. And yeah, we're short format. Our longest race is 15 minutes in our multi-car, where we have 8 cars racing each other. And that's, you do 2 laps, pit stop, where you do a driver change, and then complete the other final 2 laps, and that's it. Winner takes all, shall we say. We have electric motors front and rear, but crucially, those electric motors are powered by a battery, which is charged by a hydrogen fuel cell. So we're the world's first FIA hydrogen homologated race car.
Really, really interesting. And the history of Extreme H is that it was born out of Extreme E, which was the battery-focused, same, almost equivalent vehicle. Is that correct?
Well, if you sat them side by side, you kind of say that yes, they're the same. Under the skin, of course, they're quite different. The Extreme E car was powered by an off-car charger. Like anybody driving an electric car these days on the road will park up at home, or charging stations, and that was what the Extreme E car technology was. It was plug in, charge, and race. The Extreme H car, as like I say, has got on board. It's got the hydrogen fuel cell, so we've got hydrogen tanks. The fuel cell charges the battery, so that's one of the fundamental differences. The other is the suspension geometry and the seating position of the Extreme H car compared to the Extreme E. We've got much revised and improved suspension geometry. So the handling of the Extreme H car is a big step change from Extreme E. And there's the seat. Another noticeable difference is the seating position. We're a central seat racing car now in Extreme H, whereas we were biased over to the left-hand side in Extreme E. So those are the big differences. Like I say, the bodywork is a slight evolution and so on, but those are the big chunks that you'd notice.
Fantastic. So you're the world's first hydrogen-powered motorsport, sanctioned by the FIA, as you say. What was the ultimate goal for Extreme H when you set off on the journey and you said, this is what we want to do? What was your why?
Our founder and our chairman, our big boss, is Alejandro Agag. And Alejandro, I'm sure you're aware, is also the founder of Formula E. He just keeps going from strength to strength. That's why Alejandro founded Extreme E, to take that, as well as racing on tarmac, to demonstrate to the world that BEVs could race competitively in very tough terrains all around the globe. So it wasn't just tarmac racing. Let's really put these cars through some tough challenges. We thought we'd achieve that with Extreme E. And so what's the next step? What's out there? Alejandro took a look around and thought that hydrogen will have a place in the future in mobility. And so we want to go and achieve the same thing again. We want to demonstrate that hydrogen-powered vehicles can operate and race in very tough terrains all around the world. That's our objective. We thought we accomplished what we needed to do in Extreme E. We wanted to move on with technology. What's the next step for mobility, for the planet,
It's interesting, obviously, because hydrogen fuel cells have been through quite a tumultuous journey over the last sort of 20 years. We know if you go down to the local space centre, you'll see there will be a fuel cell that was helping astronauts go certainly into space, if not the moon. And the fuel cell technology has been around for quite a while, but the promise of it becoming a mainstream technology has been a sort of long-term promise. So as people look at it and the investment in fuel cells has been a little bit lower, you must be really championing the fuel cell it's people that are worried about hydrogen, and there's many different ways of powering using hydrogen, as we know, but using it specifically in the fuel cell. What do you say to the critics that say hydrogen doesn't have a place in general mobility, in their opinion?
You can track back from steam engines to oil and gasoline cars, and you can keep going forward, wind all the way back and wind forward, and you'll always have critics at any stage. And I'm quite sure that there were people who were immensely worried about having a tank of fuel in a car back in the early 20th century, for example. Motorsport has got a history of developing fast new technologies, where an OEM might have some latency in its systems and so on. And in fact, I was reading an article only this morning. Similarly, where motor racing teams are helping out aerospace companies right now in the UK because of their speed. That's what we think we can bring to this. Hydrogen has got, in some quarters, some nervousness around it. We've been racing with it. It's another fuel. We plug the car in, charge the car up, and we charge the tanks with the hydrogen. Hydrogen fuel cell goes to work, charges the battery, and then we go racing. Part of our mission is to dispel a lot of these myths, but also provide a platform for hydrogen fuel cell suppliers or manufacturers or car companies to come and race their technology. That's one of our big motivations.
And you talked earlier, actually, it's an interesting point just to pick up on the motivations of the OEMs, because you're looking to take Extreme H from being a World Cup, which is a defined beginning and end championship, if you like, series of events, into being a world championship event. You're looking for the future of Extreme H to really attract in a wider audience to come in and invest.
Yeah, I mentioned it earlier on that we're the world's first FIA-homologated hydrogen race car. We have got tremendous support from the FIA. In fact, I was only on a call with them earlier on today. Tremendous support from the FIA in putting on the world's first hydrogen World Cup last year. We are in Qiddiya in Saudi Arabia. We have another World Cup planned for this year in October 2026. 2027 we want to expand. We've got the World Cup again, but we want to expand 2 more events. And the objective for us is to become an FIA World Championship in 2028. We have the full backing of the FIA with this, and it's very much a live project and a live initiative that we're working towards.
I mean, as a thoroughbred motorsport person that you are, before we delve into some of the more interesting technical aspects, the idea of a 2.2 ton truck, which is approximately what it is that right? It's like an X5 weight, really, vehicle, thundering through sand dunes. What is it like being there, Mark?
So you're absolutely right. The weight of the car has gone up from Extreme E to Extreme H. And the majority of that weight, yes, we've accommodated a fuel cell. But a lot of that weight was also part of this homologation process I've spoken to you about with the FIA. So we've got deformable structures, impact structures left and right that are mandated by the FIA, and also extra protection on the underside of the car and above the tanks, including a carbon composite bridging device that shields the hydrogen fuel tanks on board. So we've got that extra mass. I think the thing that has impressed most of the drivers who drove the Extreme E car compared to Extreme H, with that increased mass, despite the increased mass, I should say, we've actually got a way better performing race car. So in turn-in, roll characteristics, how the car takes the jumps. These guys who drive these cars, when they're in the air, they actually, would you believe, they fly the car? So they go on and off the throttle and they spin the wheels up. And that has an aero effect, which means they can kind of almost control the angle of the car while it's flying through the air. That was very difficult in an Extreme E car. In an Extreme H car, these guys can fly the car. So it's incredible talent that these drivers have got, and and then landing again, and how they put the car into a pitch and make the car turn in. All of that, it just feels more natural to them in an Extreme H car. So credit to the Spark team. They've taken a big step forward in performance, despite the fact that we've had to add weight because of that homologation processes and those crash tests and everything that we've had to undergo to satisfy the FIA. So it's quite an achievement.
It is, isn't it? And I suppose for the doubters out there, the crash tests are significant. I think I've seen very high G loads that you have to go through. Hang on, is it 17 G crash test or something like that?
No, the 17G was actually some of the lows that we saw in racing. So a spike of 17G in vertical when the cars were landing, that itself is quite a test of man and machine. We've also, we had to go through some very stringent crash tests with sledges being driven into chassis at 65 kilometers an hour with various different shaped impact structures on them to prove out that the chassis, the race car chassis, could sustain all of these, in the event of an accident would be okay, and the hydrogen system wouldn't get damaged. And I'm glad to say that we passed all of those tests with flying colours. So again, credit to the Spark design team.
And a slight deviation from the main vehicle, you also have a grid independent strategy with Extreme H, which is about being able to refuel and power everything from hydrogen off infrastructure. Is that correct?
Yeah, that is. Arguably, even Extreme E was hydrogen powered, because winding back to Extreme E days, what we have on site is 2 hydrogen fuel cells that power the paddock. They supply something in the region of 20 megawatt hours of power to the paddock, and then we've got a smaller fuel cell that's powers all the hospitality, and I think that's 5 megawatt hours that's capable of. We have 2 solar arrays that can deliver 150 kilowatts. So again, you can see that independence. We don't plug into a grid anywhere, unlike, let's say, Formula One, who turn up at the garages and they're plugging into the mains power. We are self-sufficient in that way.
And it's a really interesting race format on that basis, because it makes sense to be independent if you're out in the desert somewhere. I know there's the logistics of the gas and getting it all there, and I'm sure there's some challenges in that. But then once you're there, you're remote, you're independent, but you're also, in theory, if the gas is green, you're sustainable. And I'm sure the other formats will be looking at what you're doing and learning from you in the future as they look at their overall CO2 footprint and talk about what they're going to do in the future.
Very much so. And I know that Formula One and the World Endurance Championship, if they've not already done it, they were moving towards hydrogen fuel cells to power their paddocks as well. So we've led the way there, and yeah, long may it continue that other championships see the light with powering their, paddock like the Formula One paddock with everything that demands. I mean, it's huge, the power drain that those guys need. So long may it continue, like I say, that other championships start to adopt hydrogen fuel cells for their paddock power.
Yeah, it must be quite the difference. And has there been any major challenges in the infrastructure side, or any great learnings that is really influencing the way people think they're going to use this technology in the future?
It goes back to what I was saying earlier. I think it's part of our responsibility to demonstrate that actually it's fairly straightforward. I remember people asking me in and around the time when we were going through the test program with the prototype race car, Mark, what have been the biggest challenges? Well, I don't want to make light of it. It's quite a boring answer, but actually, it's been fairly straightforward. We've got a great hydrogen fuel cell from Sambio, French company. Spark, our racing car partners, designed a great car. It was installed. We passed those FIA homologation tests, and we went testing. And by and large, the car was very reliable from the get-go. And then we rolled back into the service area. We had our refueling rig, we refuel the car, and then we go get testing again, back out on track. And I think the more people understand that it can be that straightforward, the more all of this, shall we say, nervousness around hydrogen starts to die away. But it's about getting that message across, and what a great way of doing it, by being out there and racing 8 cars side by side, leaping through the air, and to your point, in in deserts and the whole thing. And if it's a great racing product, people will watch it, and then all of a sudden hydrogen won't be this thing. It'll just be, well, those cars are powered by hydrogen. Okay, great.
Absolutely. I think it's fantastic, Mark. I find it a particular interest because I worked for many years in hydrogen fuel cell R&D development company, and one of the opportunities many years ago was tendering for hydrogen fuel cell rechargers for the original Formula E, and the company I was at were not interested in being part of it because they didn't feel it was part of their wider future, which I absolutely at the time was very, very sad about, because I could see both the PR opportunity for the fuel cells that would come, the longer format, but also just the testing ground that is motorsport, which, as you well know, it's a fantastic place to prove and test technologies. So it's really nice to see somebody else equally along that journey has done that, achieved that, and put that technology in place to power and recharge batteries, as well as, like you say, the solar setup and other renewables that I'm sure you'll have over time.
Yeah, I mean, it's been embedded right at the heart of Extreme E, and which was a championship that was set up while I was still at McLaren. As I say, I put together the McLaren Extreme E team, and that was my introduction to the championship. Those messages there have been, and that philosophy were embedded right into the heart of Extreme E and carried over into Extreme H. We could have carried on with Extreme E, but let's not stand still. Let's keep moving forward and grab another technology that's out there that for sure will be playing a part in future mobility. Absolutely, it will be. How big a percentage that is, I'm not sure. I don't know, and I don't think anybody does. But it will play a part, and so why not be out there racing with that technology?
Absolutely. In terms of the vehicle itself, when you look at going from Extreme E to Extreme H, you've added weight to the vehicle to add the hydrogen fuel cell overall to the structure, and you've sort of traded off some battery to move into hydrogen, because fundamentally the hydrogen fuel cell is recharging a battery, and it gives an element of range extending, but it's not a huge amount of range extension. It's already a short format category anyway. Whilst it's probably not been a technical overall benefit for doing it, where does it really shine to you having the dual source hydrogen for other people watching this? Because you could say, well, you could stick it a battery format, playing devil's advocate. you could have stuck with just a battery and not proven hydrogen. At the moment, the hydrogen fuel cell is not contributing significantly to the range of the vehicle, but it is making some contribution. Where does it go from here in the future when you're planning it?
So at the moment, we've got 25%, 75% split with the fuel cell and the battery. We have agreed with the FIA a technical roadmap that shifts over time that the authority, so that in the future what we want is a more authoritative fuel cell than the battery. That's part of that technological journey and development. And if we haven't got a fuel cell in the car, you can't do that. You can't go on that journey. But this is where we've started. It's a good starting point, and we know what we want to achieve in the future and shift that balance of power to the fuel cell and away from the pack. But at the moment, it is all charged with hydrogen. That's for sure. The pack is charged up by hydrogen, by the fuel cell, and then continues to do that through the race. So that's all legitimate. But what we want to do in the future, like I say, is to shift that balance of power towards the fuel cell.
So you'll be looking at the roadmap for the power output of the fuel cells to increase those. Obviously, the balance of plant and then the gas storage will have to move in line with that. And while you downsize the battery equivalent.
Within what we have already on the car, the tanks that we have, the capacity of those tanks, how much gas we can put in those tanks can be achieved with the tanks that we've already got. So then you're either going to up the power outage of your fuel cell or your distance that you want to race. For us at the moment, what we'd like to do is keep those distances the same, stay a short format of racing, but raise that power outage of the output of the fuel cell in the future. And we've got all that within our gift.
Yeah. Fascinating stuff. And you talk about the storage tank. Have many people been very much doubters on the gas storage? So you're having to use hydrogen, as you well know, and not everybody knows. It's either gaseous or you have to cool it in liquid, store it, and that is its own balance of plant difficulties and complexities to keep it cool enough. So it tends to be large tanks because hydrogen doesn't have a very high energy density, certainly compared to petrol and other liquids.
Yep.
What is a challenge for you when thinking about the either duration of the races or the formats? Does the hydrogen become a limiting factor in the future on what you want to do, or you don't see it that way?
No, the tanks that we use are actually Toyota Mirai hydrogen tanks, composite fuel tanks. We run currently at 250 bar, and if for everybody watching, bar is pressure, okay, but actually think about it in terms of filling your petrol car up and let's say you've got a 10-litre tank. Well, we're filling like 2 litres of fuel, hydrogen. We can actually go to 700 bar. That's what the tanks are rated to. So that's that capacity I was talking about earlier on. With that, we don't really have a challenge. We've got that option to, like I was saying, mentioned earlier on. We could extend the range of the races if we increase the pressure in which we fill. We have got exclusivity with the FIA to be a gaseous championship. We've got that H2 gas. Nobody else can come along and set up a H2 gas powered championship. The FIA have got 2 streams running, if that makes sense. They've got us with gas, and they've got the World Endurance Program with H24, it's called, with their liquid hydrogen technology. It's very difficult. Liquid hydrogen, I'm not going to dress it up, is very difficult, and gas in many ways is easier. We just charge the tanks, and then the tanks feed the fuel cell, and away we go. You've not got all of that complexity of a onboard cooling system that has to keep that hydrogen refrigerated and therefore in liquid form. It's quite a challenge, but again, I applaud those guys. They're having a go. As a world, as a population of the world, we can't just sit back and we've got to look at all these different options. We can't just sit back and say, hydrogen never work. That's not in the spirit of pushing forward in great engineering undertakings.
Yes, and it's interesting to hear because I agree in terms of motorsport is the place to really try this stuff and push the boundaries of what's possible and using creativity in a competitive environment, because that does drive people in a different way. When you're looking at hydrogen specifically as a fuel source, was there ever any point that you considered using hydrogen in a traditional engine called an ICE, internal combustion engine? And one of the questions being PEM fuel cells, or proton exchange membrane fuel cells, require very high purity hydrogen, as you'll know. That comes at a higher grade, higher cost, higher complexity, and production. You can use dirtier, which we call it dirty hydrogen, but less pure hydrogen, easier to make. And you can use it in theory in a combustion engine, albeit you need much larger tanks because of the energy density. Was it ever a consideration to use less pure hydrogen in the more traditional sense of an internal combustion engine?
I think that technology and that path is a path well trodden, and it was considered, but where we've alighted on, what the solution that we've alighted on, I think actually gives an opportunity to push the fuel cells hard and develop those. You can take a look at a hydrogen fuel cell and you could think it might be some sort of fragile device, whereas we've put it into this race car, that 17G vertical spike that I was talking about, and and guess what, they didn't all break. We had, apart from one car that had a minor problem that caused it to have an accident, but it was an assembly error, I should say, rather than a design error. We would have had 8 cars completing our first World Cup final. So to get back to your question, we didn't see the point in just propagating or keep going with combustion engine technology, even if it is powered by hydrogen. I think the opportunity lies and still lies with hydrogen fuel cells. Plus the fact that hydrogen combustion still produces NOx gases and so on. You'll know with your history that all we're getting is water coming out the exhaust pipe.
Water and air.
Yeah.
Actually, do you have much trouble with air intake and the sand in the intakes? Is that a challenge on the...
No, that's a very good question. And we've obviously got very large air intakes. Hydrogen fuel cells, as you'll know, are air hungry, but we've got great filtration. So no problem whatsoever. It was never a concern.
You're carrying around a bag of sand by the time you finish the race and someone needs to empty that.
Yeah, and that's it. The filtration works really well, and actually even that wasn't so bad. You'd think you'd get some restriction and all the rest of it. It was fine.
Yeah, it's interesting because obviously the desert offers some of the harshest environment realities in, certainly for combustion engines. And when you move into jet propulsion and jet engines, helicopters suffer. I've worked on projects where helicopters engines were operating in the desert. They're ingesting sand when they're hovering near the ground. That sand gets melted onto the compressor blades. That shortens the life of the engine. There's all kinds of challenges in sand. So it really is one of the harshest environments to prove a technology out in many ways. Really interesting. So brings me up to one of my final areas that I like to talk about, and that's really the translatability of all this to the, let's call it, the automotive, potentially other. I mean, it's not limited to automotive. It's got defense, aerospace, potentially rail, all kinds of applications that are interested in hydrogen fuel cell. And talk about the brilliance of motorsport, and I'm biased in saying that because I believe it as well, to test and prove these technologies to help OEMs find solutions more quickly than they can take on and scale and mass produce.
I agree with everything you just said. I've been in the company of several representatives of OEM's motorsports division over the last 6 months. And I keep hearing the same message from them, even though they're working for Honda or Toyota, Ford, whatever it may be, GM. What the future looks like, whether that's synthetic fuels, keep on drilling and getting oil out of the ground, hydrogen, solid-state batteries, so on. The honest answer is none of us know what that future is. Probably it's a combination of all of them, right? We won't all just be on solid-state batteries, or we won't all be driving a hydrogen car and getting on a hydrogen-powered train or whatever. But the one thing, and that we all agree on, and kind of you could say, well, yes, because you're all working motorsport, is let motorsport be the test bed. Let motorsport trial all of these things and then feed that information back to the motherships everywhere, back to Tokyo, back to Dearborn, back to Detroit. Let it motorsport do all of this work. Prove out these technologies rapidly, because your next deadline is your next race. Very harsh conditions, because by nature of motorsport, you're really pushing your vehicle hard, whether that's a Grand Prix car, whether that's an off-road racing car like ours, whether it's a 24-hour racing car. It's hard, it's tough environment. Let motorsport prove out all these different technologies faster, and then let the mothership use that information, use that data accrued, use that technology to push forward for all of us in our daily drive, or like I say, on a train or wherever it may end up.
And do you think the OEMs are good at doing that currently? And I talk across motorsport. Do you think they're really sharpened? Because often it becomes a brand exercise where they get some material benefits, but it does sometimes seem the days of when they used to directly take technologies and cascade that into the future of automotive, for example. It's not always very transparent. I know that the current F1 regs have been redone to try and help prove that, because they ended up with, more extremely difficult technologies in the previous gen of Formula One cars that weren't going to be used in the road. So have you seen it really translate in a way that you'd like to?
So again, another very interesting question. Some of the things I'm picking up on are there's been a bit of a pushback on the technology that's involved in Formula One at the moment, because there's a perception, rightly or wrongly, that it's taken away driver skill, and it's, what the true essence of Formula One was about isn't what we've currently got. So then you want your drivers to be these big, valiant superheroes driving these cars on the limit. And of course, that's what Formula One is always about. But also Formula One has always been about technology and pushing technology forward. Formula One as a championship, and Liberty and the FIA have got this balancing act at the moment that they're trying to decide which way that will move forward. Are you going to take away all that push to develop technology and be a much more basic car, but that's a real challenge for a driver and so on, and the fans equally. Where do they fit in with all of this? Of course, that's a very, very tough balancing act that they've got in front of them. I think for ourselves and for the guys who are pushing hydrogen liquid in sports car racing, in some ways we've got a much easier task, in that we can provide that racing still without it's not going to detract from a driver's ability or the fans' enjoyment of the sport. But we are pushing ahead with new technology. So it can't be said of all categories of racing, but for motorsport definitely has a place to keep advancing new technologies or refining existing technologies and still providing great entertainment for motorsport fans.
Which it ultimately is an entertainment.
It's very easy to lose track of that. I'm working for a championship now, but when you're working for a team, you kind of don't. Sounds quite brutal, but you're there to win. And if you win a race by 5 minutes, I'll make up any old number, but if you actually obliterate all of your competition, well, you've done your job, haven't you? And if that was a boring race for the fans, who cares? We've won, we've got more points, let's move on to the next race. Sounds brutal, that's a reality. The job of a championship, my responsibility now and Stefano Domenicali and so on is to make sure that you've got a great racing championship that provides a fantastic platform for the teams to try to do, be better than the next teams alongside them and all the rest of it, but make sure that your fans are engaged with it. Those are tough challenges. That's it. That is the very nature of motorsport.
It is indeed. And one thing I'm curious on, you mentioned you've got exclusivity on hydrogen gas in motorsport. Are there visions for other formats?
Well, I'd say the stated aim is to move to being a World Championship in 2028. We remain open to changing our formats. We won't ever go away from mandating a male and female driver. That equality is, again, right at the foundation of what we are as a championship. But we remain flexible on what our formats are. We had great feedback and great success with our first World Cup, and using the time trial and the head-to-head and like I say, our multi-car races. So they were very successful. We had great fan feedback. So for sure, that's where we are at the moment, but we could increase the range of the car quite easily. Working hand with the FIA, we know that would be an option. So we remain flexible on that, and we would investigate all options as we work towards 2028.
I get it's kind of an answer without an answer, but it's interesting, the format and the potential that you've got in the future.
I think that's the thing. We've got a format that we're very comfortable with carrying over from Extreme E. We are the world's first hydrogen World Cup. We do want to be the world's first hydrogen World Championship. So it's about moving forward fast enough, but not making errors along the way. We want to get it right each time. We want to build on the success of last year's World Cup. We're going to say in October, we're back again in Qiddiya, which is going to be the motorsports capital centre for racing in the Middle East and certainly in Saudi Arabia. So we're working hand in hand with the Qiddiya team there to push on and develop our capability in that area. But we're just about getting it right and working towards the goal of 2028.
Yeah, and I don't underestimate how big a challenge it is to take one series event into many series events, going
Yeah.
presumably into different countries and picking, in your case, the different places that suit the environment, the harsh environments that you're looking for. It's going to be no mean feat to logistically pull that together with all the sponsors, the people, the drivers, the equipment.
I mean, to be classified as a world championship, we're going to need to race on 3 continents. So we're in the Middle East already. We want to be in Europe, and ideally we're racing in North America as well. So
yeah, exciting stuff. So tell me, Mark, where can people find more about Extreme H and follow what's going on?
I'd just point everybody into the Extreme H website. It's all there. We do have a presence on all of the usual platforms with podcasts and so on. Specifically, we will be racing again at the tail end of October in Qadir, pulling back some of our drivers from last year. And I mean, previous drivers that we've had in the championship and involved in the championship have been Sebastian Loeb and Carlos Sainz, for example. So high caliber drivers with multiple world championships. Jansen Button has a team that races with us. His team raced in the World Cup last year and will be racing again with us in this year's World Cup. So that's a bit of a taster for where we're at as a World Cup, and you can see how that will expand and develop as we move towards World Championship.
No, fantastic. Well, thank you so much, Mark, for joining me on Future Engineering Bets.
That's quite all right.
And if you're watching this or you're listening to this, please do share this episode with people that you think will like it. Don't forget to follow. Have a look at Extreme H. It's a fascinating series in motorsport that's really pushing the boundaries with hydrogen fuel cell. And I'll see you on another episode.